periodic trend in properties of elements. So we studied in periodic table there is a periodicity is present. What is a periodicity? Periodicity means periodical repetition of elements with similar properties after certain regular intervals when the elements are arranged with increasing atomic number. When we are arranging elements in the increasing order of atomic number, there is a regular repetition of properties, repetition of elements with the similar properties. Elements are repeating, not same element. Elements are repeating with the similar properties within a regular interval. This we call it as periodicity in properties. This periodicity in properties having some trend. Trend means some pattern. For example, we studied the group 1 elements are highly reactive. So when we are moving down alkali metals or group 1 elements, they are highly reactive. But at the same time, when we are moved down halogens, the properties, chemical reactivity decreases on moving down. That means when we are moving from left to right in the periodic table, if we are talking about chemical reactivity, first it increases. Then when we are moved from left to right, it decreases. Towards the middle of the series, the periodic chemical reactivity decreases. But towards the end of the series, for halogens, it is very high. This we call this pattern is called trend. There are lot of properties. For example, atomic radii, ionization enthalpy, electronegativity, electron gain enthalpy. These properties are called atomic properties. These properties having a close relations with the electronic configuration, and also these properties indirectly influence or indirectly it affect melting point, boiling point, enthalpy of vaporization, atomization, etc. So let us discuss something about the periodic trend in atomic properties such as atomic radii, ionic radii, ionization enthalpy, electronegativity, etc. The first property which we are going to study is atomic radii. So what is atomic radii? Atomic radii is the distance between the nucleus and the outermost electronic level of an atom is called atomic radii. You know the definition? What is atomic radii? Distance between the nucleus and the outermost electronic level of an atom is called atomic radii. So atomic radii is the important factor which describes the size of the atom. Because the size of the atom we can say only from atomic radius value. Size of the atom play an important role for the properties. Most of the properties of elements depends on size of the atom. So it is a very important factor, that is atomic radii. What is atomic radii? Distance between the nucleus and the outermost electronic level of an atom is called atomic radii. But measuring a radii of an atom is not so easy. Why? Because one of the point is atom is so small. So it is very difficult for us to measure. Second reason is there is no specific method to measure the radius of an atom. And the next point the theory which we are following, or the wave theory, says that nucleus is surrounded by electron cloud. That means, based on wave theory, atom is, there is a nucleus, the nucleus is surrounded by some electron cloud. Since nucleus is surrounded by a cloud of electron, there is no specific boundary for the radius, for the atom. Then how can you measure the distance between the nucleus and outermost electronic level? Oh, it is very difficult. Because of that, the size, measuring the size of the atom is very difficult. We simply define the atomic radius, but measuring the boundary very difficult. So it is very difficult to measure the radius of an atom. Usually, radius of an atom is measured by X-ray method, by using some X-ray. Or it can be measured by some spectroscopic studies. So now, we studied the atomic radius varies based on the bonding. When the bonding varies, automatically atomic radius also varies. For example, when sodium form ionic bond, its radius is 186 pm. Whereas when it form covalent bond in vapor phase, it form covalent bond, its radius become 154 pm. That means when bonding changes, automatically the radius also changes. Because of this factor, measuring the radius of an atom is very difficult. Because of this last reason, we are calling atomic radius by different names. Let us discuss one by one. First one is, in some cases, the atomic radius is called covalent radii. Where atomic radius is called covalent radii? From the name we can understand in metal, in covalent compound. In covalent molecule, atomic radius is called covalent radii. For example, if two hydrogen atoms are bonded covalently, so two hydrogen atoms are bonded to covalently, then how can you measure the distance of hydrogen? So how can you measure this? This is one hydrogen atom, this is another hydrogen. We are measuring the distance between the two nucleus. The distance between the two nucleus is called internuclear distance. By measuring the internuclear distance or from the internuclear distance value, we are taking half. That is considered as atomic radii of hydrogen. In the case of hydrogen, when it is bonded covalently, the internuclear distance is measured as 74 pm. So from that, how can you calculate atomic radii? So atomic radii of hydrogen is 74 by 2, that is equal to 74 by 2, 37 pm. This is the covalent radii of hydrogen atom. What is covalent radii? Atomic radii in the case of covalent molecule is called covalent radii. Can you clear? Atomic radii in the case of covalent molecule. How can you measure covalent radii? By measuring the internuclear distance, or by taking half of the internuclear distance, we can calculate covalent radii. Similarly, we can study metallic radii. So metallic radii, from the name we can understand it is for metals. So when in the case of metal, we are calculating atomic radii in the same way how we calculate covalent radii. In metallic radii also, by measuring the internuclear distance between two metallic bonded atom, and we take the half as considered as atomic radii or metallic radii. For example, sodium, when it is bonded, two sodium atoms and it bonded, first we have to measure internuclear distance. Then we have to take the half of the internuclear distance. That is considered as metallic radii of sodium. For example, the metallic radii of sodium is 186 pm and that of copper is 128 pm. So how can you measure metallic radii? By measuring the internuclear distance and take the half of that. That is considered as metallic radii. But one of the important things you have to remember is metallic radii is always larger than covalent radii. Why? Metallic radii is larger than covalent radii. Already I told you the metallic radii of sodium is 186 pm, whereas sodium, when it forms covalent bond, its radius is 154 pm. So covalent radii is somewhat smaller than metallic radii. Why? The reason behind this is a covalent bonding is formed by overlapping of atomic orbitals. How covalent bonds are formed? Covalent bonds are formed by overlapping of atomic orbitals. Since it forms overlapping, the bonded atoms are more nearer. And also the bond is more stronger. The bonded atoms attract towards each other. But this is absent in metallic radii. Therefore, covalent radii is smaller than metallic radii, or metallic radii is larger than covalent radii. Now listen here, if in the case of inert gases, there is no bonding is present. They are all monoatomic atom. How neon? Neon means neon only. It has no covalent bond or no metallic bond. Why? Because it is having completely filled outermost electronic configuration. So they are not forming any bond. So automatically the two neon atoms are taken. How the neon? This is one neon means nearby another neon is present. There is some gap between there. There is no complete attractive forces acting between one neon and another neon. So automatically there is a small gap. This gap is called van der Waals gap. And the force of attraction which hold good two non-bonded atoms. The force of attraction which hold the two non-bonded atoms is called van der Waals force. Van der Waals force of attraction. Therefore, the radii measured by measuring internuclear distance in two non-bonded atoms is called van der Waals radii. So listen here, van der Waals radii means the radii, atomic radii in the case of two non-bonded atoms or molecules. Van der Waals radii means it is the radii formed between two non-bonded atoms. Van der Waals radii is always larger than metallic radii and covalent radii. Why? Because of the van der Waals gap. between non-bonded atom, some gap is present. They are not fully attract towards each other. Such bonding is called van der Waals radii. Now we have to study about the periodic trend in atomic radii. Periodic trend in atomic radii means how the atomic radius varies when we move from top to bottom as well as when we move from left to right. When we move from top to bottom, usually atomic radii increases. When we move from top to bottom, atomic radii increases. Why atomic radius increases? Because when we move from top to bottom, the atomic number increases. When atomic number increases, automatically nuclear charge is increasing. But the incoming electrons are occupying different energy level, or the value of principal quantum number is increasing. So the valence electrons move furthest from the nucleus. Automatically atomic radii increases. But when we move from left to right, when atomic number increases, automatically one proton increases in the nucleus. When number of proton increases in the nucleus, the power of the nucleus increases. That power of the nucleus is called nuclear charge. When nuclear charge increases, it attracts the valence electron towards itself. At the same time, the incoming electrons are occupying same energy level. The two reasons are playing when we move from left to right. What are they? One is nuclear charge increases. Second one is the incoming electrons are occupying same energy level. Atomic size decreases when we move from left to right. When we move from left to right, atomic size decreases. When we move from top to bottom, atomic size increases. Or in otherwise, when we are moving down a groove, atomic size increases. Why atomic size increases? Because of the increase in energy level. When we move from left to right, atomic size decreases. Why it decreases? Because of the increase in nuclear charge as well as the incoming electrons are occupying same energy level. Next, atomic property which we are going to discuss is ionic radii. What is ionic radii? Radii of an ion. So what is an ion? Ion means when an electron is removed or added to a neutral atom, the resultant species is called ion. For example, you know sodium. Sodium, the atomic number is 11. Atomic number means number of electrons or number of protons. We studied atom is electrically neutral. Why? Because it having 11 protons. At the same time, it having 11 electrons. So the net charge is 0. No charge sodium having. So that is why sodium is called sodium atom. Now, by some suitable means, if you remove one electron from the sodium, what happens? Number of proton is 11 only. We have removed only electron. So now the electron is 10. So if we add, what we get? Plus 1. Now the neutral sodium atom having 1 plus charge, we represent it as Na plus. This we call the sodium atom. This is called sodium ion. Similarly, in the case of chlorine, you know chlorine, atomic number 17. So chlorine, what about the atomic number? Atomic number of chlorine is 17. So it has 17 proton and 17 electron, net charge is 0. That is called chlorine atom. By some suitable means, if we add one more electron, then what happens? Number of electron become 18. When we are adding these two, what we are getting? -1. Now chlorine is represented as Cl minus. This is called chloride ion. Thus, we are having two ions. One is positive ion, another one is negative ion. Positive ions are normally called cations, negative ions are called anions. So, ions means charged species. We are having two types of ion, positive ion and negative ion. The radii of an ion is just like atomic radii. So, we studied atomic radii means distance between the nucleus and the outermost electronic level of an atom. Similarly, ionic radii means distance between the nucleus of an ion and the outermost electronic influence of that particular ion is called ionic radii. There is a great difference in atomic radii of cation and anion. Usually, cations are smaller than parental ion. When we are comparing sodium ion with the sodium atom, the sodium cation is smaller. When we are comparing chloride ion with fluorine, chloride ion is bigger or larger than fluorine atom. Why? We have to study. For what we study now? Cations are smaller than parental atom, whereas anions are larger than parental atom. Sodium having 11 proton and 11 electrons. If we are removing one electron, automatically we will get Na plus ion. The sodium ion having one electron lower than parental atom. Cations having less number of electron than parental atom. But both parental atom and Na plus cation having same number of proton in the nucleus. No change in the nuclear charge. But number of electron decreases. Nuclear charge per electron increases in the case of cation. What is increases? Nuclear charge per electron increases in case of cation. Therefore, cation possesses smaller atomic radii or smaller radii when we compare with the parental atom. Sodium ion having only 10 electrons, but 11 protons are there. More attractive force. So automatically size is smaller. But at the same time, if we are consider anion, for example Cl minus ion having 17 proton but 18 electrons. So the nuclear attraction or nuclear charge depends only on 17 proton, but it having 18 electron. Now nuclear charge or nuclear attraction per electron decreases when we compare with the parental chlorine atom. Therefore, anions are larger than parental atom. Now let us consider potassium. You know potassium atomic number is 19. So it having 19 proton and 19 electron. Suppose if we are having K plus, if we are considering K plus only one plus means one electron we have to remove. So number of electrons present in K plus is only 18 electrons. Similarly, if you consider Cl minus, you know it having 17 proton. But Cl minus means one electron we have to increase, so it will have 18 electrons. Both K K plus. Consider K plus and Cl minus having same number of electrons. So the ions which having same number of electrons are called isoelectronic ions. These isoelectronic ions are otherwise called isoelectronic species. What do you mean by isoelectronic species? The ions which having same number of electrons are called isoelectronic species. What about nuclear charge of isoelectrons? Different. When the nuclear charge difference, automatically the size may vary. The size of isoelectrons vary in accordance with the nuclear charge, but they are having same number of electrons. What about isoelectrons? What do you mean by isoelectron? Species or ions having same number of electrons are called isoelectron. What about the size? The size varies based on nuclear charge.